Hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we are going to go through a couple of popular mathematics Q&A and also a little bit background about myself. I'm in the final year of my graduation and I'm doing my graduation in aerospace engineering. And if you need any homework help or if you need any tutoring help or one-to-one sessions, then you can check the links in the description below. So let's just begin with our questions. So we have first question as So the first question is, just a minute. Yeah, so the first question is, we need to solve y prime double prime plus 2y equal to g of t, and we have the boundary conditions as y of 0 as 0 and y prime of 0 as 0, and we have been given g of t as 0 if this is y is between 0 to y is between 10 to 20. This will be not equal to, and 0 if t is greater than equal to 20. So these kind of differential equations are basically the ordinary differential equations. So first I will go for, since for this condition and for this condition it is 0, so I'll just find the derivative or the equation of y for 0, and it will be equal for the interval of 0 to 10 and in the interval for more than 20. So first I will take for, and hence my boundary conditions are same for all the intervals, so I don't have to worry a lot. So for this should be t, I think. Yeah, this should be t. I'll just rub this and write t. T is 20 and then t is, so for t equal to 0 to 10 and more than 20, so we have the differential equation, which is, and this y is the derivative of t with respect to t, so y double prime will be d square y by dt square, and my y will be just y only. So I'll just write the differential equation, and this will be y equal to 0. And now I'm going to say that now in the ordinary differential equation we have the liberty of converting this d of dt into capital D. So we are just substituting this d over dt, the operator, differential operator, as capital D. So if I substitute this, then I will get d square y plus 2y equal to 0, and then this will become, I'll take y common, so d square plus 2 times y equal to 0. Now we'll go for, we have two kind of solution in this ordinary differential equation. One is the particular integral and the other one is the it was called the CI. I cannot remember the full form. One was PI and one was CI. So we are just going to go with the one because in the right hand side we just have a constant number, and if it was a function of x or if it was a function of independent variable, then we would have taken the particular integral also, but in this case we are just going to solve for ci. So this d square plus 2, I can write this as m square plus 2 equal to y, and I'm going to solve this equation. So scroll down. So here what I should do is that m will be plus minus of root 2. So this will become plus minus root 2 times I. So this is a complex function or the complex values, and for complex values we have the general equation as y equal to c1 sine x plus c2 cosine x plus the constant function which we have here, and it will be 0. Now we are going to put the boundary conditions. So the boundary conditions which we had was y at 0. Basically when x is 0, y is also 0. So I'll put y at 0, and then x is 0, so this will become c1 plus no, sine 0 is 0. So sine 0 is 0 plus cosine 0 is 1, and this one is 0, so this is c2 is 0. So my equation will become y equal to c1 sine x. Now I'll put y prime of 0 is 0, so I'll just take the differential. I'll take y prime, this will be c1, and this will become derivative of sine will be cosine of x, and then at y prime is 0 when x is 0, so cosine 0 is 1, hence my c1 is also 0. So eventually we are ending t between 0 to y and greater than 20. Now we will be going through for the condition of this, for this dotted lines, and for the condition of t between 10 and 20. So this will become y double prime plus 2y equal to 1 plus 2y equal to g of t, and g of t is 1. Okay. Now again I'll put the differential operator here. So d square y by dt square plus 2y equal to 1, and then I have yep. So I'll just substitute this as capital D square y plus 2y equal to 1, and this will become t square plus 2 equal to 1, and this will be again equal to 0. Now this constant is not this one, so we whatever the expression we have in this bracket, we just um, equate that equation to equal to 0. So m will be again imaginary, and for imaginary we have c1 sine x plus c2 cosine x, and the constant here is 1, so it will come. I'll just go with the just check their solution. Okay, so here they have taken as 1 over 2. We get this as y prime is equal to 0 for a constant solution. Therefore, well, this should be equal to 1 only. I'm not sure if they are correct. Okay. Okay. So in the above one, it was not sine x. It is basically sine of lambda x. So instead of just x, we'll have a root 2 here, and again here also we'll have a root 2, because this value of m will come with the sine. So this particular value, and here also we'll have that value. So y will be equal to c1 sine root 2x plus c2, and this will become cosine of root 2x, and I have the habit of writing x, but this will be t. So keep in mind that this will be always be t, because we generally have the habit of writing the differential equations in terms of y, x and y. And then for the constant term, let me just verify this. They have taken yp as general solution. Yp is particular solution, satisfied non-homogeneous equation, and this will be for yp. Okay, yeah. So for integral, so this is the general solution, which is the c1, and for particular integral, what we'll do is that we'll just divide this, and what was this will, so e power, this will be 0x, and this will, so d square will become minus minus of a square, so this will be equal to 0, and yeah, okay. So for particular integral, what we'll have is that we'll just take the RHS part. Oh god, I'm again and again writing this 1 over 2. This will be just 1. And now we are going to divide this one with d square plus 2. Now for this one, we don't have any general formula for the constant one. So what I can do is that I can just write e power 0x, and basically e power 0x is nothing but 1. And whenever we have a function with the a function like e power ax, then my t square will become a square. So this will become 0 square, and this will become 0, so this will become 1 over 2. So my yp will be 1 over 2, and my y will be yc plus yp. Scroll down this page, So my total y will be c1 sine root 2 t plus c2 cosine root 2 t plus this will be 1 over 2. Now again we'll put the boundary conditions to this. I'll not take the derivative, sorry. This will become sine 0 will be 0 plus cosine of 0 will be 1, c2 plus 1 over 2. This gives c2 as negative 1 over 2. Now we will go for the second boundary condition. So we'll just substitute the value of we'll not substitute the value of c2 right now. So we'll just take the derivative and will become, and this is c1. This is sine, so this will become cosine c1 root 2 plus this will become minus this will become sine c2 root 2 sine root 2 t, and this will become 0, and for t as 0, so cosine of 0 will be 1 minus sine of 0 will be 0, and this is c1 root 2 times 1, so c1 will be 0. Hence we get y as c1 is 0, the sine term will be 0, so it will be negative of cosine root 2t plus 1 by 2. So this will become 1 by 2 minus 1 by 2 cosine of root 2t. So I can take 1 over 2 common minus cosine of root 2t. So let's just check the solution given by the junior tutor, and the solution given is the same, and for the last interval again we'll have 0, so I can finally write y of t will be 0 1 minus cosine of root 2t 0, here t will be 0 to 10, t will be 10 to 20, and t will be greater than equal to 20. The solution given here is correct. So how to find or relative extrema of the function? So this is again going to be a lengthy one. So we have question number 2. Function is given as minus of x cubed minus 6x squared minus 9x minus 2. So first I'll write the condition for extrema and means minima and maxima. So for minima and maxima, what we do is that we take first derivative and then this will be equal to 0, and then whatever x will be there, so whatever the value will be, we'll obtain for x will be the points for maxima and minima. Then we'll take second derivative and we'll substitute the value of these x, these points, and then if it is positive, then it will be minima. If it is negative, then it will be maxima. So first I'm just going to take the derivative of this function. So this will be dx of f of x will be minus of 3x square minus of 12x minus 9 minus of 3x square minus of 12x and minus of 9, and we'll substitute this to 0. So 0 is minus 3x square minus 12x minus 9, and I'll just multiply both the sides with minus 1. So I just divide both the sides with minus 3. So this will become x square minus 4 plus 4x, and this will be plus 4x, and this will be plus 3. Now I'll just take the factors. So x square plus x plus 3x plus 3 equal to 0. X plus 1 plus 3 times x plus 1 equal to 0. So x plus 1 plus 3 equal to 0. So x will be negative 1 and negative 3. So these are the points of maxima and minima. Now what I will do, I will take the second derivative. I will take the second derivative. So this was the first derivative, and I'll just take the derivative of this again. D square dx square f of x. This will be 3 to the 6, so minus 6x minus 12. Now for x equal to minus 1, we have minus 6, 1 minus 12. So this will be negative. And for x equal to minus 3, this will be minus minus plus, and this will be negative of 6. So x equal to minus of 3 minus 6 into minus 3. So this will be 18, and this will be positive. So this is going to be the maxima, and this is going to be the minima. Now we'll just find the coordinate, because we have the x coordinate of the maxima and minima. For y coordinate, we just plug in the values of x and of these x in the function. For f of x at x equal to negative 1, this will be minus 1, and this will become minus 6 plus 9 minus 2. So this is minus 6 minus 1 minus 7, and minus 8 minus 9. Minus 1 cube will be minus 1, then 1 square will be 1 minus 6. This will become minus plus 9. So this will be 0, I think. Yeah, this will be 0. So my coordinate will be negative 1 comma 0 for this was maxima. For minima, I'll take f of x equal to negative 3. So this will be 3 3 9 minus 27 and this will be square 9 and 6 are 54, and this will be 3 9s are 18, minus of 18, this will be plus minus 2. I'll just take my calculator for this one. Minus 27 minus 54 plus 18 minus 2, minus of 65. This will be minus 3 minus 65. I'll just cross check with the solution given by Junior Tutor because I'm not sure that these were the coordinates. F of minus 3. Okay, I think I have done some mistake. So this will be minus 1 cube will be, oh god, this was already in minus. That's why I was kind of confused. X equal to -1, so -1 this will be plus 1, and 1 square, so this will be minus of 6, and this will be plus of 9 minus 2, so this will become 1 minus 6 plus 9 minus 2. Yeah, this will be 2. So for point of local minima and max local, this maxima will be -1 comma 2, and for minima x equal to -3, we'll have 27, and this will be -54 plus these are 18 minus 2, 27 is coming out to be minus of 11, but here they have 27 minus 54, this is plus 27, this and this will get cancelled. Yep, this will be 27 minus 54 minus plus 27 minus 2, this will be minus of 2. So for minima I have -3 comma -2, and let's just go through the solution given by Junior Tutor. So we have this first derivative, then they are taking first derivative, finding the points, and then they are finding the maxima and minima for um 0 to like infinity to 3. This negative sign is not coming here, but this is from negative infinity to negative of 3, and then they are finding for -4 the value is negative, and then for -3 to -1 value is positive, and again it is going negative. The first derivative changes sign twice, it goes from being negative to being positive around x equal to -3. which means that this critical point is a local minima. And then for again we have the maxima. So x equal to -1 is the maxima and x equal to -3 is minima. Here we have the coordinates, so this will be negative and negative, and this is also negative. The sign is not printing in this platform right now, so but this is negative definitely. So correct solution. Good work. So I have question number 3. So what is the derivative of an absolute value? An absolute value. So we need to find the derivative of d over dx where u is the function of x. So u is the function of x, and we have a direct formula for this, which is u over magnitude of u into du over dx. So let's go with the example given by Junior Tutor. X minus 2 and okay, so here the function can be written as the root of x minus 2 whole square, and they'll use the property of derivative of x power n is x power n 1 times n. So they'll will take the derivative here and will get 2 times x minus 2 over 2 times 2 whole square. Then we just simplify, cancel, and magnitude of u is nothing but under root and square of the u. So this will be like x square plus y square plus square. So this is the way we find the magnitude. So here we have dy by dx, which is u over magnitude of u. This will be x minus 2 or u over magnitude of x minus 2. Oh god, I'm just again writing this minus 2. And du by dx will be x minus 2 will be 1. So let's just find the one more derivative. Let's just take the example for y equal to x, just x. Now for magnitude of y, this will be magnitude of x. With the rule, we can say this will be x over magnitude of x, and derivative of dy by dx will be 1, so this will be the answer. So in this way we find the derivative of absolute value of any function. So correct solution would question number 4. So we need to use the divergence theorem to calculate the surface integral here. So x we have, the function we have will be x e power y I cap plus z minus e power y k cap, and this is minus xy k cap, and the surface is the ellipsoid, which is x square plus 2y square plus 3z square, which is 4. Now the divergence theorem is f dot ds will be converted to volume integral, and this will be divergence of f into dv. Now for this, first we are going to calculate the divergence of f. So divergence of f is nothing but the I component term, we just write it as x, and j component term, so this is nothing but j component term, and this is the with k component term, this will be the k component term. So I can just take the derivative. Divergence of f will be, so this I component term will be x e power y, so we are going to take the derivative with respect to x. This will become e power y, and plus with y, this will be constant, so this will be 0, so this will become minus e power y, and for xy there is no z term, so this will be 0, and we can say that divergence of f is 0, therefore f dot ds will be 0, because if this term is 0, then there is not that, then the integration is not going to go. So the solution given by Junior Tutor is also the same, so it is correct solution. Good work. Three, 4, 5. Yeah. I'm sorry for the delay. Now we have the antiderivative. This will be question number This was question number 1, 2, 3, 4, 5. Question number 5. So we need to find antiderivative of or integral of sine inverse of x. So for this, what they are doing is, let's say t is sine inverse of x. So x will become sine of t, and if I take derivative, then dx will become cosine of t dt. So I'll substitute the value of x and the value of dx. So value of x is sine of t, sine inverse of t will be t times cosine of t dt. And for this and to evaluate this integral, we are going to use the um, I don't remember the exact name. Yeah, integration by parts. So integration by parts was like, and the dx was, will take u times minus derivative of u into integral of dx times dx. So this is the formula for this. So here I'll take the constant function as t, and so t will be my u and my v will be cosine of t dt. So this will be t, and integral of cosine t dt will be sine t. This will be minus, and then derivative of u will be 1 integral, and this will be minus of sine t. This is multiplied, and this will be dt. So it will become minus t sine t, and this will become plus, and the integral of sine t is cosine of t, and we'll have a constant of integration. Now I'll substitute the value of t as minus of sine inverse of x, and this will be sine of sine inverse of x will be x, and this will become plus, and we'll have cosine t sine inverse of x. This will be cosine of sine inverse of x, and I can write this as 1 minus x square under root of cosine inverse of, and this will become minus x times sine inverse of x. So this will finally become minus x sine inverse of x plus under root of 1 minus x square. I'll just cross check with the solution given by Junior Tutor. So they have used the similar formula. Again, I'm saying that these minus signs are not getting printed here because there might be some issues. This is x, then the sine inverse of x plus 1. This will be minus, and yeah, I forgot to add this c. C was always here. It was here in this step. So again, solution given by junior tutor is correct. So correct solution. Good work. Then we have, this was fifth question. 1, 2, 3, 4, 5. Now we are going to have question number 6. We'll have question number 6. This will be, we need to find first derivative and second derivative of, so my x will be e power t, my y will be t times e power minus 1, and we need to find dy by dx and d square y by dx square. So first I'll find dy. It will be, dy will be, this will be 1 e power minus 1, and my dx will be, this will be dt also, dx will be e power t dt. So my dy by dx will be e power minus 1 dt over e power t dt will be 1 over e power t plus 1. So let's see what the junior tutor has given for this one. So for this one they have taken dy by dt as e power t, and this one they have taken dx by dt, this is e power minus t, and this is in multiplication. I'm not sure that why they have taken like this. Dy by dt is t times e power minus 1. E power minus 1 will come in the denominator. Dy by dt e power minus t 1 minus t. So I think they have assumed that this is t times e power t. Write like this as e power t, then derivative will be 1 times e power t plus t times e power t. So this will become 1 plus e power t. But the question is different here. The derivative is in terms of, okay, so they have given the wrong solution here. Okay, so the solution given by junior tutor is not correct here. I'll just proceed with my solution, because if we take the derivative of y, then this e will become 1 and e power minus 1 is a constant term, and so this is dy by dx 1 over e power t plus 1. For second derivative, what we'll do, we'll take d dt of dy by dx and d over dt. So this will become like d square y over dt and dx, and this dx will become whole square, and this was dt, so dt and dt will get cancelled. So we will get d square y over dx square y. So these differential operators work like this only. So we'll take, because these functions are dependent on t, therefore we need to go for this approach. So my second derivative of y with respect to x, so this will be dy by dx 1 over e power t plus 1 over, and this will be dx over dt. So my dx by dt was e power t. This will be e power t, and this will be e power, we'll use the power rule. This will be e power t plus 1, and this will be minus, and so this will become e dt, and this will be e power t. This will be it will be minus e power minus of t plus 1 minus e power minus of t plus 1 over e power t, because if we take this as u, then there is no square term, so this dt will become du, and e power minus of u will become minus of e power minus of u. So I can write this, and I can take back this in the denominator, e power t times e power t plus 1, and this will become minus of 1 over, and the bases are same, so we'll add up the power 2t plus 1. D square y over dx square is minus 1 over e power 2t plus 1, and dy by dx is 1 over e power t plus 1. So for dy by dx, the solution given here is wrong, and for this one also the solution given here is not correct. Condition is the curve is concave upward. Nope. So this is going to be the solution. So solution given here is incorrect. d2y over dx2 will be minus of 1 divided by e power 2t plus 1, and dy by dx will be 1 over e power t plus 1. The solution given here is incorrect. Now, 4, 5, 6, question number 7. So we have question number 7. What is the power rule for derivatives? So we have used power rule in the previous questions also. So power rule of derivatives. So this is nothing but if we have, let's say if we want to find the derivative of x power n, it will be n times x power n minus 1. So let's say I'm taking derivative of x power 5, so this will become 5 times x power 4. If I'm taking derivative of, let's say, x power minus 1, so this will become minus 1 times x power minus 2, because minus 1 will become minus 2. Again, we have derivative of x power, say, 100. This will be 100 times x power 99. And let's look at the solution given by Junior Tutor. So the power rule for derivatives is used to find the derivative of the function consisting of a variable that is raised to a power. For example, x power 5, x square inverse, and y cube. Then we have this formula and correct solution. So that is pretty much for the power rule, because there is nothing much for a power rule, and the power rule is basically the easiest rule of the derivatives. Correct solution, good work. Yeah, so we need to find the derivative of sine inverse of x. We need to find the dx of sine inverse of x. So let's say sine inverse of x as q, then my x will become sine of u, because if I multiplied sine with on both the sides, then this will become x equal to sine u. I'll take the derivative on both the sides. Dx will be, derivative of sine will be cosine du. Then I'll just divide by du on both the sides. This will become dx over du will be cosine of u, and now basically I need to find du by dx. So this will become 1 over cosine of u, and cosine of u is nothing but under root of 1 minus sine square u, because we have the identity of trigonometry, sine square u plus cosine square u equal to 1. So with this we can take this sine term on that side and take the under root, and we'll get this. So du over dx will be 1 over under root of 1 minus sine square u, and this sine square u is nothing but sine of u whole square. And if I keep the value of u as sine inverse of x, sine of x, this will become x, and we had the whole square, so this will become x square. With sine square u will become x square here. This will be 1 minus x square, and this is the derivative of sine inverse of x. So let's look at the solution given by Junior Tutor. So 1 over 1 minus x square, correct? So correct solution, good work. And that is pretty much all. Yeah, so that is pretty much all for this session. And if you like this session, then please do hit the like button and subscribe also to, and please do hit the bell icon also to stay updated with our next live streams. And my name is Devansh Purohit, a senior tutor at OneClass, and I'll be seeing you in the next video. So till then, bye.